Hello students, you're watching the Unreal Numbers, and in this video we are going to talk about relations and functions for class 11. It's applicable for both the boards CBSE and ICSE. First of all, we need to know what is an ordered pair. So it can be any pair of element written in the form of x, y within the parenthesis. Here you need to remember that the order is important. That means if you reverse the order pair and it becomes y equal to x, they are not equal. That means the order pair 1, 2 is not equal to the order pair 2, 1. So here the order is important. Now how is it useful for us? To understand that, let us understand the Cartesian product of two sets A and B. The Cartesian product of two sets A and B is a set having the order pairs of the form x, y, taking the first element from A and the second element y from B, and it should have all possible combinations. So our A cross B will have the members, will have the order pairs like 1, A, 1, B, 2, A, 2, B, and so on. In fact, if you try to understand it carefully, it should have 6 order pairs all written in your screen. Now, I have a question for you. What is the set B cross A, you think? Yeah, you guessed it right. It should be having all order pairs taking the first element from B and the second element from A. So it should have order pairs like A, 1 or A, 2. I want you to write what will be B cross A in the comment down below. So let's try to generalize the idea that how many members will be there in the set of A cross B if the set A contains P number of elements and the set B contains Q number of elements. As we are taking all possible combinations, so for each of the P elements in A, there should be Q number of pairs forming, taking the elements from B. So in total, there will be PQ number of elements. That is the formula that we use to find out number of elements in A cross B. Now there's a question for the viewers that if A is a set having 3 elements in it, then what will be the number of elements in the set A cross A itself? And I also want you to write down all the elements of A cross A in the comment. Let's come to the relation. What is a relation? As the name suggests, a relation is something that relates a set to another set. So mathematically, the definition is a relation is any subset of the set A cross B. So it will be a relation from A to the set B. Okay. So let us try to understand by an example. In the previous example only, as we have seen, we know all the elements of A cross B. Let us pick a subset R. Let us pick a subset R from the A cross B. I can take randomly any few elements from A and B. So let's say in this R I am taking 1, A, 2, B and 3, B. So 1, 2, 3 they are elements of A and they are being connected to A and B, which are elements of the capital B. As you can see in the diagram, 1 is connected to A, whereas 2 and 3 both are connected to B. But if you notice carefully, the element 1 is not connected to the element B. So a relation may or may not connect a particular element from the first set to a particular element of the second set. Those elements will be connected who are related by that particular rule, whichever rule that that relation gives you. Let us try to understand it better by another example. Can you look at this is a tree or maybe a family tree. These are the members A, B, C, D, E, F, G, H and so on. They are the members of this family and I am drawing a tree. Whenever I write plus, that means that member is a male, and whenever I write minus, that member is a female. And when I write them together, they are couples. Like A and B are couples and they have their children C, D and E, and their correspondingly their husbands and wives are written here. So I define a set X having all members of this family. So X will have 13 elements, as we can understand, starting from A to M. Now, I define a relation M which will have the order pairs where M contains all possible order pairs x comma y such that x is the mother of y. Okay, so in this relation, as you can see, D is related to L because D is the mother of L. But in the same way, A is not related to B. A is not the mother of B. So M relation relates D and L. It contains the order pair D comma L, but it does not contain the order pair A comma B. Now I have a question for you again. Can you give me one order pair which belongs to the relation B where B contains all the order pairs x comma y such that x is the brother of y? Give me one order pair that belongs to B and give me an order pair that does not belong to B. So the key idea that we want to understand here is that M and B, two different sets, rather I should call them subsets of x cross x, and they relate different elements of x to different elements of x again. Okay, so that is the key idea that we can take away from here. Let's see another example. See, the best way to understand mathematics is by examples. So I'm giving you more and as many examples as I can. So here, as you can see the relation written, it will contain all the x comma y if it follows the rule. You can think it as like the R is a house. Okay, let's say it's your house. So in your house, you must have a rule to live in that house. Like your parent has given you a set of rules that you come back from play within like 7 at the evening, okay? And then you study, then you have your dinner, then you sleep early. These are the rules we have to follow. What happens if you don't follow the rule? Your parents will kick you out. Okay, at least they will scold you. So this is how works the things work here as well. R is a house and it has a set of rule. Whichever order pair follows that rule, those order pairs can stay in that house, other are not allowed. So let us try to understand which order pairs will live in this house and which are not. Okay, so we can see y is equal to x plus 12 by x. X and y both should be natural numbers. Okay, what does natural number mean? The positive integers like 1, 2, 3, 4. They both should be positive integer. Now there is a very important thing to observe here, that y is not a natural number if x does not divide 12. So x can take values which are the factors of 12. For example, 1, 2, 3, 4, 6 and 12. And accordingly, you get the values of y. If you put x equal to 1, you get 13 as the value of y. If you take x is equal to 2, you get the 6, you get 8 as the value of y, and so on and so forth. Okay, so the R relation will have these order pairs written on your screen, which are members of that set. And if I try to represent the relation by an arrow diagram, it will look like this. 1 is connected to 13, 2 is connected to 8, similarly 6 is connected to 8 as well, 12 is also connected to 13, 3 and 4 both are connected to 7. Now we jump into our next segment, that number of relations from a set A to a set B. Let us assume that A has m number of elements and B has n number of elements. Then we know that we already derived that A cross B must have mn number of elements. So we know that a relation R is any subset of that A cross B set. And we have also studied in sets that a set can have 2 to the power n subsets if it has n number of elements. Now A cross B has mn number of elements, so it should have 2 to the power mn number of relations. Now I want you to ask that why this 2 to the power n formula? Rather, you think about this question and we are going to discuss that in our permutation combination video of this series. The main topic of relations, it's the domain and range of a relation. try to understand a relation as a machine. What does a real life machine do? You think about any machine, let's say a juicer. What does it do? It takes input of fruits and it gives you output of juices, right? So any machine does that. The simplest way to explain their work is it takes input, it gives you output. Relation is also the same. Any relation that takes an input and gives you an output. For example, in the previous relation, as we have seen, whenever it takes 1 as input or 12 as input, it gives you 13 as output. Whenever it takes 3 and 4 as input, it gives you 7 as output. Whenever it takes 2 and 6 as input, it gives you 8 as output. So that is the idea of any relation. So in a relation, think it like this. If you try to input any other number other than 1, 2, 3, 4, 6, 12 in this R machine, the machine will not work, it will break. Okay, like in your juicer, if you try to put maybe sand and stones, it will not give you a juice of that, right? Isn't it? You have to put in fruits there, then only you can get juice. So there is a certain field that you can take inputs from, right? So that set where you can take inputs from is known as the domain of the relation. Okay, what is the domain of the relation? The set of all possible inputs. And the set of all possible outputs is known as the range of that relation. I hope this is clear. So in the next video, which is going to come very soon, we will discuss when a relation is called a function. Thank you for watching. For more videos like this, be subscribed to my channel and keep supporting. Okay, if you like this video, don't forget to like and share it with your friends. Thank you again.